part A, here's one way you can say it. There is a strong positive linear association between size and selling price there is an unusual point, and that would be that little guy right out there near 4,000 square feet and a selling price of about 500,000. Okay, so that is a there I addressed the strength, the strong. That we use the strong as the adjective. So first, there's a strong positive. There's my direction. Linear. There's my form. And then I use the context between. You could have gone more into between the square footage of a house and the selling price of the house. You can always add a little bit extra in there, but you want to make sure you're going to say that in context. You got to do that. Our outlier or our unusual point is the one that's sitting far away, and then that's it. So again, as we look at this is a 4-point problem. The whole problem is 4 points. The investigative task, and the way that things are broken down, multiple choice is 50% of the test. FRQs 1 through 5 is 25% of the test. FRQ number 6, 25% of the test. So this investigative task, that's what we're doing right now, it's 1/4 of the test on your score. Okay? So it has a greater weight compared to some of the other ones that when you look at it. So it's one that you definitely want to make sure we try to get through as much of it as we can. We do get a separate 30 minutes for it, so we do get time. And so as we look at the parts here, if we don't answer that part in that kind of way, with all that stuff there, now you automatically got a P for that part. Now, if you didn't answer that part, you got an I. Because they basically will go through each of the parts, they'll say E, excellent, P, partial, I, incomplete. And it's a combination of how many E's and P's does it give you 4 points, and so forth.
If you just put like the key points, do you have to make it all a sentence like that?
You do not. They would prefer it in a sentence. I'll be honest with you. That way you tie in the context. Because that'd be the one thing I see. If you just list down strong and then positive, linear, and you say unusual point 4,000. I mean, I find it. They want it a little bit nice, kind of this big. So because again, that's the first part, so it sets the tone on your approach. So I would make it kind of nice and sweet like that. So again, as you look at it, in order to get the 4 points, it's mainly getting all E's on the different parts. Getting 3 points is a couple E's and a P, and so forth as you go through. So this is the one we don't want to lose any points on because it's the easier compared to some other parts. Part B, it says in the region, houses are considered large if they are greater than 2,500 square feet and expensive if the selling price is greater than 300,000. The following two-way table summarizes the house in the sample. Use the information in the table to construct a graphical display of the data. So now as we look at this one, we want to make sure as you do your graphical display, you want to make sure that you draw and label axis, both axes, the axes. You want to plot your values. Now, that doesn't mean we plot ordered pairs, but we're going to plot our values. We want to make sure we provide a key. We got to provide a key if needed, and then also we want to make sure identify the variables. And that goes, the variables is basically like your labeling of the axis. We know, when we label the axis, we think about putting the scale down there and doing things, but we want to make sure we use the two things that are there, or what we're talking about, the selling price and then house size, and as our major variables there. Here's where we have choices. What do we want to do? Is the information quantitative or categorical? The stuff that's listed there, the way it's listed, is it a categorical or is it a quantitative? It's what? Yeah, it's categorical, okay? Because we're really not going to add those things up. We don't have the exact dollar amount, so we can't add up and divide and get a mean and stuff. So that means it's not going to be quantitative. So, so when we're looking at a categorical graph or information, usually a segmented bar graph is the best one to do. So we're going to do a segmented bar graph. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 100%. So as I label my axis here, I'm doing percentages on this vertical axis. So this is my relative frequency. And again, we're going with basically 10% and up is what we're doing. Again, if you want to, since I labeled that, I would go 10, 20, 30, 40, blah, 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 is I would label that. You can use the decimal points if you want to. If you're going to go 0.1, 0.2, 0.3, you can do that. On our horizontal axis, we have basically large and not large. And this would be our, when we look at our thing. Again, they have a couple options here. This is the size of house. And so I'm going to do my segmented bar graph here. So now, in order to figure out, I got to basically take and find what percent of the houses are expensive that are large and so forth. So I need to go through and carefully, as we look at not large, so there are 2 houses that are not large that are expensive, so that would be 2 divided by 18. And then this one would be 8 divided by 12 for that one. So I need to basically take each of these ones divided by the column total at the bottom. So that would be 4 out of 12, and this would be 16 out of 18. So looking at percentages, just to make it easy, I'm going to go with 2-digit percents. If we do 8 divided by 12, we divide top and bottom by 4, and we get 2/3. So that's 67%, or that's about 67%. That means this other part here has got to be about 33%. And then 1/9 would be 11%. And then this one would end up being 89%. And then now we would go over to our graph, and I'm going to start off with the large first. And then this is where, once I do this, and again, on a paper, you're not going to have color. So as we do this, we know we have to have a rectangle that goes all the way up to 100%. So we have to do that for both of them. They always have to go up to 100%. And then now, my first section, I'm going to do expensive first. for large, 67%. So 40, 50, 60. So somewhere about here, that's going to be, and I'm going to, again, this is what you're probably going to do on the test. As you do your key, we're going to say expensive. And we're going to draw what that pattern looks like. And then not expensive, we'll draw another pattern. And then, so not expensive, I'm going to go with just dots. I'm going to just go dots in there. So for my not expensives. And then now I go over to the not large, I do the same thing. For the expensive, there's 11%, so just a smidge there. Draw the same pattern. And then the other part gets the dots. Again, we don't have the benefit of using color pens on the AP test, so we're kind of limited to that. So I labeled my axis. I've put my keys. I've used the variables, size of the house, and so forth. Yes, dear.
Sorry, does it matter what variable you put?
No, as long as you adjust it, if you put down like expensive and not expensive, and then you chose house side or whatever price, then you'd be fine, and then your key over here would change and stuff. Which probably, when you look at it, you'd be dividing by these other numbers, and so they would have two examples and stuff on there. Because again, when you'd be dividing across, you would be saying this number divided by 10, that divided by 10, and so forth. So you'd have different percentages is what you'd end up having and stuff. Yes.
So initially, I would.
Could you go a side-by-side bar chart? Sure.
Okay.
Yeah, you can do a side-by-side. You know, there is some flexibility on, you know, okay, what are you doing? You just got to make sure label correctly, so forth, and you're kind of going from there. Okay. Sometimes it's a little bit more forgiving in this area here to do a segmented bar chart because we know it's got to go up to 100, so I really don't have to worry about both of the individual bars getting to the exact height because I just got to find the middle part since there's only two things. And you know what I mean? So that's where the suggestion of doing that one is usually the easiest on there. But again, there's flexibility. You know. All right, so there's part, again, I think both part A and B are definitely doable. And so it's like, hey, let's try to maximize getting 2 E's out of these parts. Now as we go into part 2, it says, assume there's no association. To me, when I start thinking about that, I'm starting to think about now, and I see it later on, it's got a chi-squared thing. Okay, is what I'm thinking, and maybe I'm doing a chi-squared testing is what it's talking about. So assume there's no association between size, such as large and not large, and price, expensive and not expensive. Use the given totals to complete the following table with expected number of houses for each classification if with no association. So what we have to, because now it matters how I divide and how I set it up. Okay? So here what they're asking, so if we assume there is no association, this statement right here, no association between size and price. Assume no association between size and price. So what we're going to do is we are going to get our, we're going to take 10 divided by 30 and 20 divided by 30, and that's going to give us our numbers that we work with. So that'd be 1/3 and 2/3, 1/3 and 2/3. And then remember when we did this, we would go back for the expected counts and we would multiply, okay, what's 1/3? What's 1/3 times 12? What is 2/3 times 12. So that would be 4, that would be 8. Coming over to the other side, 1/3 of 18 is 6, and then that would give us 12 in that part. Again, do we, how can I check to make sure I did that right? Yeah, I can go ahead and stick and try to do the chi-squares, put in a matrix and go ahead and do a chi-square, the chi-square test, just to see if I got the right things in that spot. Okay. But it's finding the percent from the last column out of the total and then multiply it by the column header bar totals at the bottom. All right, so for associations of plate in a scatter plot, the strength of a linear association is measured by the correlation coefficient. So in our picture up here, they said the correlation coefficient of that graph there. Whoa, where'd you go? All over the place. All right. So they told us the correlation coefficient is 0.82. For associations that are summarized in the two-way table, the strength of the association is measured by the chi-square statistic. The formula for the chi-squared is as follows. We're expected is the count assuming no association, and observed is the count shown by the data. Greater values of x squared, of chi-squared, stronger association. Okay? The bigger the chi-squared statistic, the stronger the association. They tell us the chi-squared statistic is 10, is what they tell us. All right, so, and then now they said, suppose the selling price for the most expensive house is the same, in this sample, went from 489 down to 325. What effect would the decrease have on the R value? Explain your reasoning. So as we go back up to our picture, we are taking this point right here, and instead of it being about 4,000 square feet to 500,000, that thing dropped all the way down to here to about 300 and some. What did they say? 325? Yeah, 325. So it drops all the way down. Keep going. That looks like about 325. So that's where it drops to. So we need to now talk about in two ways. First, we got to talk about the R value. How did it change, and how do we know, and so forth. Okay. Then we have to talk about what is it going to do to the chi-square statistic. Is it going to change that? Okay. So we just can't say, hey, it's going to go down, or it's going to increase or decrease. We just can't say one word. We got to give a reasoning behind it to get the full credit for that part. So, what do you all think is going to happen to that R value? If we move that sales price down to 325, what's going to happen? Is the R value going to increase, or is it going to decrease? It's going to decrease. I agree with you. Okay, so it is going to decrease. So we will say for this first part, the R value, sorry, I'm on the eraser mode. The correlation R would decrease again, get closer to 0. Because, here's our reasoning, because the point would no longer be in the linear pattern of the rest of the data. So our R value would decrease. It'll go from whatever it was, 0.8 or 0.9 or 0.82. It's going to get smaller. We don't know how much, but it is going to get smaller. It's going to get closer to 0. It may pull us down to the 0.6. May pull us down to the 0.5s. Because again, that point is that is, when we think about the residual, right, the current point right now, in our picture, the residual value is not that big. So it doesn't have a big impact on it because it's close to the least squares regression line. Whereas when we drop this thing down, now it's going to have a bigger residual, which is going to have a greater impact on the R squared, on the R value, and as we calculate stuff. So there's the first part. Part 2, what effect would it have on the chi-squared? So we went from 489K to 325K. So would we change categories? What was the cutoff for expensive? What was the cutoff for expensive? 300. So the cutoff for 300,000, or for expensive, cutoff for expensive is 300K. This house didn't change categories. And since it didn't change categories, is the chi-squared going to change? No. Therefore, the chi-squared statistic is not going to change. Again, the reason is when we look at observed minus expected, the observed is not going to change. The observed value is not going to change. It's still going to be in that category. So therefore, our chi-square statistic is going to stay 10 as we do it. So we've now talked about those two. All right. Part D, based on your answer to Part C, explain one benefit and one drawback of using the chi-squared. What's one benefit and one drawback? Well, here's a benefit. A benefit. The benefit of using the chi-squared is that it is somewhat resistant to unusual points. Rather than the R value. When we are using it to measure the strength of the association. Okay. So there is a benefit. Hey, it's more. We're not going to say it's totally resistant, but it's somewhat resistant. Okay. I'm going to turn off the lights. That way we can see what's on the screen. A little bit easier. It is somewhat resistant to it, to the unusual points. Therefore, it's better to use it for talking about the strength of the association. A drawback. So a drawback could be that all expensive / large houses are treated the same. And therefore, some information is lost when measuring the strength of the relationship. Okay. And that is the end of the problem. There's no more other subparts. So that was a nice kind of, in a way, short, sweet. We never know how big this investigative task problem is going to be. One of the other ones I got that we're going to do here in a little bit has more stuff involved. It's more labor intensive. And again, the goal hopefully is to scratch and claw and answer as many subparts as E as we can, even if we get to, let's say, this last part, and I really couldn't come up with a drawback. I could come up to maybe a benefit. If I had a couple E's and then I had an I, then I'm at least getting 2 points on this problem. I might get 3. You know, if you leave the benefit and the drawback totally blank, they would give you an I on that part. And so I could see most likely 2 E's and an I. Let's see, how many parts did we answer? We had. Is that the fourth part? Because we had the beginning, the graphing, the what is the effect? So, So there, I mean, if the first 3 parts, if the first part, second part, third part, if you were great on all those and got E's. And then all of a sudden you drew a blank on this one and got an I, then you're probably going to get a 3 out of 4 is what you're going to get on that one. And I think that's doable. I mean, I think maybe with the interpretation that I just wrote down for the last part, hopefully as we review and we keep going, we'll keep that stuff kind of in mind as we get closer to the test. But I definitely think getting a 3 out of 4 on this part is not a challenging thing to do. Which also means, hey, that's 25% of the test score. Okay, so I do want to try to get at least a 3 on this one question because it's weighted so high compared to all the other FRQs. The challenge is it is the last question to come back. So by that time, you're pretty much toast mentally. You're pretty much fried because you've already done all 45 multiple choice questions. You've already gone through 5 free response questions in 60 minutes. And you're in that last 30-minute phase and it's like, okay, I'm done. I'm done with testing. I'm ready to be done. And so that's where sometimes we feel so overwhelmed. So it's hard to get all those points, but some of them are really doable and stuff on there. So again, that's putting together a lot of topics. When you think about it, is taking the stuff from the very taking the chapter 3 stuff, the linear regression, describing that, going back into the drawing a graph from the very first 2 chapters. I think it's technically chapter 1 in the unit. Drawing a segmented bar graph. Now we skip down to the chi-squared stuff to get the expected count. So that goes back into now chapter 12. And then we go back to, saying what happens as we change things. And then we finish up with a comparison. So